Hello students, in the previous lecture we have taken different coordinate systems, and also we have taken a significance of curl, divergence, uh, we have taken, and gradient also. So in this lecture we will start next topic, that is Coulomb's law, and next we will take electric field intensity. So first we will take Coulomb's law. Here the statement of Coulomb's law. So what is Coulomb's law? The force between 2 point charges is proportional to the product of charges and is inversely proportional to the square of distance between them. So force between 2 point charges is proportional to the product of charges. As per this statement, force between 2 point charges is proportional to the product of charges, that is the Q1 into Q2. So consider this figure. Point charge Q1 is mentioned here, and point charge Q2 is mentioned here. So as per statement, force between 2 point charges, this force between 2 point charges is proportional to the product of charges, so proportional to the product of charges, and inversely proportional to the square of distance between them. So f is inversely proportional to the r square, where r is a distance between 2 point charges. Here, if we combine this above two equation, we'll get f is directly proportional to the q1 q2 and inversely proportional to the r square. Here, if we remove the proportional here equal to, then proportionality constant k comes here. So f is equal to k q1 q2 upon r square, where q1 q2 are the charges expressed in coulombs, r is distance between two charges in meter, and f is a force in newton. So f is force in newton. So this is a coulomb. We has state this Coulomb's law. Proportionality constant. In the previous equation, k is there, which is a proportionality constant denoted by k, where value of k is given by 1 upon 4 pi epsilon, where epsilon is the permittivity or dielectric constant of a medium. Epsilon is given by epsilon 0, epsilon r. Epsilon 0 is a permittivity of free space. Here, value of this epsilon 0 is given by 8.854 into 10 raised to minus 12 farad per meter. And in problem solving, this value you have to recall. So keep in mind this value. Then if we calculate the value, then we will get this type of a value, 1 upon 36 pi into 10 raised to 9 farad per meter, where here epsilon r is a relative permittivity. Then epsilon r is equal to 1 for free space, and hence equation previous slides equation is represented as f is equal to q1 q2 upon 4 pi epsilon 0 r square for free space. The force is a vector quantity having both magnitude and direction. Therefore, in vector form, this Coulomb's law can be written as q1 q2 upon 4 pi epsilon 0 r square ar cap. So this is a vectorial form of the Coulomb's law. So this is a vectorial form of the Coulomb's law. So in the exam, state and prove Coulomb's law. So statement, and this is a proof of a Coulomb's law. So next, different forms of a Coulomb's law. So we have two different forms of a Coulomb's law. The general form of a Coulomb's law, F is equal to K into Q1 Q2 upon R square. This is a general form of a Coulomb's law. Coulomb's law for free space is given by F is equal to Q1 Q2 upon 4 pi epsilon 0 R square. Vector form of a Coulomb's law is represented as F bar is equal to K into Q1 Q2 upon R12 square into A12 bar or A12 cap. Relation between force on Q1 and Q2 is given by F2 bar is equal to minus of F1 bar, and this relation is important for problem solving. Then Coulomb's law is linear, that is F2 is equal to minus F1. See? Next slide. So we have derived Coulombs law. Next is a electric field intensity. Next in this subject term is a electric field intensity denoted by E. So to derive expression for electric field intensity, consider a point charge Q1. So this is a point charge Q1 located at the center. Suppose this charge is located at the origin of spherical coordinate system. So this charge is located in a spherical coordinate system. Now consider one more positive charge Q2. So consider this positive charge Q2. Then if we will move Q2 closer to Q1, if we move Q2 closer to this Q1, then Q1 exerts some force on Q2. Then this Q1 exerts some force on this Q2. Since Q1 is placed at the origin of spherical coordinate system, this force is directed radially outward. Since Q1 is placed in a origin of spherical coordinate system, this force directed radially outward. As mentioned in this figure, this force is radially directed radially outward. If Q2 comes more closer to Q1, Q2 comes more closer to Q1, then this force increases. That means as distance between Q1 and Q2 increases, the force on distance between Q1 and Q2 decreases, force on Q2 increases. So this is a basic, that is we have to consider Q1 and this Q2 charge. Then next, proof of electric field intensity. As previously mentioned, we have derived mentioned theoretical explanation, that is Q1 Q2, Q1 positive charge in spherical, Q2 positive charge as mentioned here. As Q2 moves closer to Q1, moves closer to Q1, then Q1 exerts some force on Q2. As distance between Q1 and Q2 decreases, force on Q2 increases. So definition, electric field intensity is defined as force per unit charge. So electric field intensity is given by ratio of force is a F12 bar upon Q2. It is mentioned as equation number 1, where F12 bar is a vector force acting on Q2 due to Q1. Here Q2 is equal to positive test charge. Here charges are placed in spherical coordinate system. So let R be the distance between Q1 and Q2. Therefore, according to Coulombs law, the force acting on Q2 by Q1 is F12 bar is equal to Q1 Q2 upon 4 pi epsilon 0 R square AR cap. So according to Coulombs law, force between these 2 point charges Q1 and Q2 is given by F12 bar is equal to product of charges and inversely proportional to the square of distance between them. Distance is in between them into AR cap. This is a vectorial notation. Then putting equation 2 in equation 1. We have to put equation 2 in this equation, that is we have to put the value of F12 bar here. So put the value of F12 bar means we have to put this value in this equation. Put this value in this equation. Therefore, we will get Q1 Q2 upon 4 pi epsilon 0 R square into Q2 under denominator term Q2. Therefore, here Q2 gets cancelled and we will get expression for electric field intensity, that is E is equal to Q1 upon 4 pi epsilon 0 R square AR cap. So this is a general expression for electric field intensity. So we have to solve problems on that also. So next is a electric field intensity E due to discrete charges, that is a or number of charges or n number of charges. Here consider this figure. When several point charges are located at different points, each charge contributes to the electric field at field point. The total electric field at a field point is a vector sum of electric field due to each source point. Therefore, let Q1, Q2, Q3 Qn be the n number of charges located at point x1 y1 z1, located at point x1 y1 z1. So mention as this as a x2 y2 z2 x2 y2 z2 and xn yn zn, n number of charges, that is xn yn zn respectively. Therefore electric field intensity E is given given by E is equal to E1p plus E2p plus E3p plus dash 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 ENP. That is, we have to calculate electric field intensity at every point. General formula for E is equal to, for E1p formula is Q1 upon 4 pi epsilon 0 R1 square AR1 cap. E2p के लिए Q2 upon 4 pi epsilon 0 R2 square AR2 cap. Therefore, here directly we have taken constant common, that is 1 upon 4 pi epsilon 0 is common for this equation. So if we take the common, in under bracket terms are Q1 upon R1 square AR1 cap plus Q2 upon R2 square AR2 cap plus Qn upon Rn square ARn cap. Here, as shown in this figure, for we can write down this above equation as 1 upon 4 pi epsilon 0 is a common, and we have written directly summation of I is equal to 1 to n Qi upon Ri square Ari, or we can take it as a n also, where Ri is the distance of point P from charge point I, and Qi is a charge at point I. Ari cap is a unit vector from I to point P. So this is a E due to discrete charges or n number of charges. So this formula is important for problem solving. If different points are given and we have to find out electric field intensity at a particular point, then we have to use this formula. Then next, Q due to line charge, sheet charge, volume charge. So total charge Q is equal to given by rho L into length L. Consider a small differential length dl, corresponding charge will be dq. Therefore, dq is equal to rho L into dl. That is a differential charge dq is equal to rho L length differential length dl. Mathematically, if we take integration, q will get q is equal to integral L dq. That is q is equal to L rho L dl. Line integral. L indicates line integral. So in problem solving, this formula is required if line charge is given, and find the point charge. If problem is given in Cartesian coordinate system, we have to take the differential length equation in Cartesian. In problem is given in cylindrical coordinate system, we have to take differential length in a cylindrical coordinate system. Then sheet charge, this is a sheet charge rho s is given by dq by ds. Therefore dq is equal to product of rho s into ds. Mathematically, q is equal to surface integral of dq. That is we have taken integral, we will get this value. Then if we take this equation integral, we will get q is equal to surface integral of rho s ds. So this is also important equation. If we in the problem we have given a sheet charge and find out point charge, then we have to solve integral. Here ds is a differential surface area. So in Cartesian coordinate system, cylindrical coordinate system, we have taken a differential surface area along x direction, along y direction, in Cartesian, in cylindrical along rho phi z, that is r phi z, along r, along phi, along z, we have taken formulas. So those formulas are important in a problem solving. Then q due to volume charge. So q due to volume charge rho v is equal to dq upon dv. Therefore dq is equal to rho v dv. Mathematically, q is equal to integral of dq. Thus from equation above equation, we can, if this integrate this equation, we will get Q is equal to volume integral of rho v dv. So this is also important formula. In some problems, volume charge density is given, and we have to solve the point charge. That is a Q is equal to V rho v dv. Here dv is a differential volume. So also we have taken in a different coordinate system. Again, that is a differential volume for Cartesian is a dx, dy, dz. Similarly, for cylindrical, for spherical, we have to put the value and solve the integral. So in the previous slides, we have taken the statement of Coulombs law, and also we have taken a proof of electric field intensity. We will take some problems on the this Coulombs law and electric field intensity. So consider this problem, understand this problem carefully. If one problem you can solve carefully in exam, you can solve any problem. So understand first, and then you can solve n number of problems. In exam, such type of problems are asked. So first problem, 3 into 10 raised to minus 4 coulomb charge is located at point m123 and charge of minus 10 raised to minus 4 coulomb at n205 in vacuum. Calculate the vector force on a negative charge. Calculate the vector force on positive charge. So here first you have to mention given data. Q1 is given as a 3 into 10 raised to minus 4 and located at point M123, and Q2 is given as a minus 10 raised to minus 4 coulomb located at 205. Therefore, from Coulomb's law, in vector form, we have written F2 bar is equal to, we have taken formula Q1 Q2 upon 4 pi epsilon 0 R square A12 cap, or AR12 cap you can mention as. So here A12 bar we have to calculate, A12 bar, so, or A12 cap we have to calculate, which is given by R12 bar upon magnitude of R12 bar, where when you calculate this R12 bar upon magnitude of R bar, that is R magnitude of R12 bar is denoted by R. Therefore, if we put these values in above equation, we will get Q1 Q2 upon 4 pi epsilon 0. Here, as shown in this figure, this is a R square term, and this this A12 cap is calculated as this R12 bar upon R. So that R square and this R square will in this term becomes R cube. So this will get this type of a formula. So in the next problems, you can directly mention formula or solve some steps. Then next is a R12 bar. So we have to find out vector R12 bar. That is R12, 2. This is a 1 point, Q1 point, 1 point. This is a second point. Therefore, we have to subtract second point minus this first point. That is a second point is given as a 205. We have to subtract this point to this point. That is a M123. Therefore, we have written, we have to write down equation for that. That is a 205 can be written as this, 205 can be written as this. That is a 2ax cap plus 0ay plus 5az. This middle term is a 0. Therefore, ay cap plus 5az cap. Similarly, we have to write down equation for this. That is R1 के लिए equation. Here coefficient is 1, therefore directly taken as a ax cap plus twice ay cap plus 3az cap. And if we subtract this equation, then we will get the value ax cap minus 2ay cap plus 2az cap. Then next is R. We have to calculate this R. Here R is given by magnitude of R12 bar, where magnitude is a coefficient square. That is a ax cap coefficient is a 1 square 1. Ay cap coefficient is a 2 square is a 4. Then az cap coefficient is a 2, 2 square is a 4. So if we calculate, we will get 4 plus 4, 8 plus 1, 9. Under root of 9 is a 3. We will get this value. Then if we keep the all the values in this equation, all these value we have calculated, and if we put these values in this equation f2 bar, we will get, put the value of q1. Q1 is given as a 3 into 10 raised to minus 4. Q1 given as a 3 into 10 raised to minus uh, uh, 3 into 10 raised to minus 4, and q2 value is given as a minus 10 raised to minus 4. So we are keep these values here. Then 4 pi epsilon 0 value we have to keep in mind, 8.854 into 10 raised to minus 12. R cube, R we have calculated, this is a R, which is a value is a 3 is cube, so we'll get 3 cube. Then next here value is R12 bar. So what is R12 bar? Is a ax cap minus 2ay cap plus 2az cap. Put that value in this equation. Then this is a calculation part. This calculation part, if you have practice, then you can fastly solve. Then after solving, we will get answer for f2 bar minus 10 ax cap plus 20 ay cap minus 20 az cap by calculating. And next we have in the problem, such first we have calculated vector force on the negative charge, that is a f2 bar we have calculated. Then next we have asked in problem, calculate the vector force on the positive charge. So for if we want to calculate vector force on positive charge, we have relation f1 bar is equal to minus of f2 bar. Therefore we will get this equation 10x negative of this equation minus plus, that is 10x cap minus 20 ay cap plus 20 az minus of f2 bar. So we have solved this problem. So in exam we can also solve technique problem. Next problem, 2 million coulomb positive charge is located in a vacuum at p1 3 minus 2 minus 4, and 5 microcoulomb negative charge is at p2 1 minus 4 2. Find the vector force on negative charge. What is the magnitude of the force on the charge at p1? Given data, q1 is given as a 2 into 10 raised to minus 3 millicoulomb. P1, this point is given, q2 minus 5 into 10 raised to microcoulomb, that is a minus 6 coulomb. P2 is 1 minus 4 2. Force on negative charge q2 is given by this formula, as previously we have mentioned, q1 q2 upon 4 pi epsilon 0 r12 bar r cube. So find out first r12 bar, which is given by r2 bar minus r1 bar, that is a 0.2 minus this first point, that is 0.1 minus 4 2 is subtracted, that is a 2 3 minus 2 4. So take in vectorial representation this notation, that is this 1 minus 4 2 is written as ax cap minus 4ay cap plus 2az cap. This 3 minus 2 4 is represented as this, that is minus 3x cap minus 2ay cap minus 4az. And if we subtract, that is ax minus 3x, we will get minus 2x. That is similarly, if we make subtraction, we will get the value of r12 bar. Then if you want to calculate the value of r bar, then which is under root of coefficient square, that is a 2 square is a 4, 2 square is a 4, 6 square is a 36. So we will get the value of under root of 44. And after getting these values, if you fill up all these value in this equation, we will get f2 bar. q1 is a 2 into 10 raised to minus 3. Then q2 is a 5 minus 5 into 10 raised to minus 6 here. And this r12 bar is value is a minus 2x cap minus 2ay cap plus 6az. Putting these values, then 4 pi into 8.854 into 10 raised to minus 12 into this 6.63, that is r value, r cube है, so 6.63 cube. And if we calculate from calculator the values, then we will get this equation. That is, after calculation we will get this equation. So for solving problem, keep calculator with you. So in exam you have to solve problems, so calculator practice must be required. So next we have asked, what is the magnitude of the force on the charge at P1? So for that we have relation, that is force on charge Q1 at point P1 is F1 bar is equal to minus of F2 bar. So negative of this equation, that is negative of above equation, is a minus 0.616 AX cap minus 0.616 AY cap plus 1.848 AZ cap. And if we want to calculate magnitude, then under root of coefficient square. If we take coefficient square, then we will get this equation. So this is the second problem on Coulombs law. Then next problem on electric field intensity. So in the previous previously we have taken derivation for electric field intensity. So take one problem, find the total electric field intensity at point 0.065 meter due to a charge of 20 microcoulomb located at 206 meter and charge of 60 microcoulomb located at 0-1 meter and charge of 100 microcoulomb located at 234. So here 3 point charges are given, 20 microcoulomb, 60 and 100 microcoulomb, and located at different places as shown in this figure. Q1, Q2, Q3 charges located at a different point. We have to calculate electric field intensity at 0.65. At this point, we have to calculate electric field intensity. So, in any problem where we have asked to find out electric field intensity, we have to subtract this point to this point. That is, we have to subtract this point 0.65 to 206, मीन्स ये पॉइंट से आपको ये पॉइंट जो है माइनस करना है, ये पॉइंट से ये पॉइंट, ये पॉइंट से ये पॉइंट. So we have expression electric field intensity, that is given by Q1 upon 4 pi epsilon 0 AR1 cap R1 square plus Q2 AR2 cap 4 pi epsilon 0 R2 square, Q3 upon 4 pi epsilon 0 AR3 cap R3 square. So here 1 upon 4 pi epsilon 0 is a common term, we have taken common, and in bracket, that is in derivation we have taken such type of a formula, the electric field intensity for n number of point charges. So Q1 into R1 bar upon R1 cube plus Q2 R2 bar upon R2 cube plus Q3 into R3 bar upon R3 cube. So if we calculate all these values and fill up the values, we will get the electric field intensity value. So first calculate this R1 bar, that is R1 bar here minus 2x cap plus 6 AY cap minus AZ cap. We have to calculate R1 bar here. This R1 bar we have calculated. Okay, minus 2 means we have subtract from this point to this point. 0 minus 2 is a minus 2x cap, 6 minus 0 is a plus 6 AY cap, right? And 5 minus 6 is a minus AZ cap. We will get this equation, and R1 bar is equal to magnitude of R1 bar. Magnitude is taken as a coefficient square. 2 square is a 4, 6 square is a 36, 1 is a 1. Then after calculating we will get value. Similarly, find out R2 bar, that is we have to find out this vector, that is this point minus this, that is 0 minus 0 is a 0. Then 6 minus 1 minus minus plus 6 plus 1 is a 7, that is a 7 AY cap. Then 5 minus 2, 5 minus 2 is a 3 AZ. We will get this equation 7 AY cap plus 3az. And if we want to calculate r2 bar, means r2, then which is given by magnitude of r2 bar, that is the coefficient square. 7 square is a 49, 3 square is a 9, we'll get this value. Then similarly calculate the r3 bar, that is this point minus this point. 0 minus 2 is a minus of 2x cap, and 6 minus 3 is a 6 minus 3 is 3ay cap, plus 5 minus 4, that is the az cap. And if we take the r3, that is magnitude of r3, which is a coefficient square. 2 square 4, 3 square 9, and 1 1, we'll get 3.74 meter. Therefore, after putting all these values in this equation, we can calculate the electric field intensity. So put all the values in this equation, and by putting all these values, we'll get the equation, that is q1 we have to fill up 20 microcoulomb, 20 into 10 raised to minus 6. Okay, and upon r1 cube, r1 is coming here 6.40 cube into this value, that is r1 bar. R1 bar is this value, minus 2x cap plus 6ay cap minus az. Put all these values in this equation, we will get after calculation we will get this value, or we can calculate the electric field intensity. So such type of problems, keep in mind that we have to find out electric field intensity here. So where the electric field intensity is asked, from that we have to subtract that point to next point, and calculate all the values of r2 bar, then we are r1 bar, then r1 magnitude of r1 bar, and similarly we can calculate, means solve other problems, such type of problems. So another problem, we will take last problem in this lecture. So find electric field intensity E at 111 due to 3 nanocoulomb point charge placed at P1 110, P2 minus 110, P3 minus 1 minus 10, and P4 1 minus 10. So here this point is given as a 1. This is a 1, this is a 1, this is a 1. So तीनों points क्या है 1 1 1, and we have to find out electric field intensity at this point, and other points are given, that is P1 ये दिया है, P2 ये दिया है, P3 and P4. So we have to for calculation of R1 bar, means R1 cap or R1 R2 bar, we have to subtract this point, that is a ये point minus other points करने पड़ेंगे. So electric field intensity due to n number of point charges, we have equation. Write down that equation here, that is 1 upon 4 pi epsilon 0 q1 r1 p cap upon r1 p square plus q2 r1 r2 p cap upon r2 p square plus q3 r3 p cap upon r3 p square plus q4 r4 p cap upon r4 p square. So here, as we observe that point charge is same for all the point charges, so we can take outside, therefore it is represented as a qa, and we have taken outside qa upon 4 pi epsilon 0, then remaining terms in brackets are same here. So only find out the factors, that is find out r1 p bar, r1 p cap, where here r1 p bar means point p minus 1 करने का है आपको. So point P minus 1 point. So point P is given as a 111 minus ये point 110. So 111 111 ये भी 1 है, 111 minus 110. So 1 minus 10, 1 minus 10, and this 1 minus 0 will get 1. This is the last term, therefore it is represented as a AZ cap. So R1 P bar will get the AZ cap. R1 P cap is a AZ cap upon magnitude of this, that is the AZ coefficient is 1, therefore 1 square, therefore we get the AZ cap. Then next we have to calculate R2 P bar. Here R2 P bar, that is point p minus second point is given as a this, therefore 1 minus 1 is 0. This 1 minus 1 is 0, 1 minus minus plus हो जाएगा, that is a 2x आ जाएगा. Then 1 minus 1 is 0 and 1 minus 0 is a 1, that is az term आ जाएगा, 2x plus az. Then calculate r2p cap, which is given by 2x cap plus az cap upon magnitude of this, that is magnitude of this is a under root of coefficient square, 2 square is a 4, 1 square is a 1, therefore we will get r2p cap as a this. Then next here, next find out r3p cap, that is point p minus, ये point p minus point 3 करने का है. First is a 1 minus 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 plus, that is a 2 हो जाएगा, 2ax cap, ये देखो. Then 1 minus minus plus 2ay cap. Then 0 minus 0, 1 minute, 1 minus 0 is a az cap. We'll get this equation. Again find out the r3p cap, that is a r3p bar upon magnitude of r3b bar, that is the same equation, write down and also make coefficient square, we'll get this equation. Similarly we can calculate r4p cap as previously, r1p cap, r2p cap, r3p cap. Similarly find out r4p cap, we will get this equation, that is we have to subtract this point to this point, fourth point. Okay, so we'll get this r1p cap, and by this is the remaining is a calculation part. We have to fill up the all the values, that is first value qa, which is given as a 3 nanocoulomb, 3 into 10 raised to minus 9 we have fill up. Then 4 into 4 pi into epsilon 0 is a 8.85 into 10 raised to minus 12. Okay, then fill up all these value. We have calculated r1p bar upon r1p, which is given by this az cap, this az cap. Okay, r1p square, r1p क्या है, 1 आया है, coefficients of this square is a under root of 1 square is a 1, therefore we have taken directly as a az. Then next is a r2p cap upon r2p square, r2p cap upon rp square, r2p cap is a this 2x cap plus az cap under root of 5, and this r2p is given by magnitude of that, that is a root of 5. So root 5 square is a 5 into root 5 we have mentioned here. Then next term, that is a third point we have to mention. We have calculated this r3p cap, 2x cap plus 2ay cap plus az cap we have mentioned here. Then this 3 is a this term r2p r3p, which is a 3 square is a 9, and remaining term is a this term, means this term we have to directly fill up here, that is 2x cap plus 2ay cap plus az cap upon 3, this is a 3. Similarly fourth term we can fill up here, and after calculation we will get the last last value of the electric field intensity. So in the your notebook you can solve this problem and find out the correct answer. So such type of problems are asked in exam, so be careful and practice all these problems. So keep in mind that electric field intensity, while solving the problem, whether the where electric field intensity has to, we have to find out at that point. So जो जहाँ पे भी इलेक्ट्रिक फील्ड इंटेंसिटी आपको कैलकुलेट करने को बोला है, वो पॉइंट माइनस रिमेनिंग पॉइंट्स करने पड़ते हैं. वी हैव टू फाइंड आउट r1p bar, r1p cap. We have to fill up the values, fill up constant values. This is here point charge is the same for all, therefore we have taken 3 nanocoulomb. In another problems value of q1, q2, q3 may be different, so according to that we have you have to solve the problem. So okay, we'll stop here, and the next lecture we will take next topic. Okay, thank you.